Hello, everybody. This is Angus from NovaStar training team. Now I'm in the Amsterdam. It's a long time no see for you guys. It's really my glad to have the training today. Maybe some of you, you're the first time to join our online NCE training. So here I just explain what is NCE. So the full name of the NCE is NovaStar Certified Engineer. We have trained more than 3,000 individuals all over the world since it started in 2014. So this time we give out 8 topic of our project, including the most basic one and how we can make a solution to the client, and also some troubleshooting and the new product operation. So I hope you guys will get all the things what you need for NovaStar system. And for this time, if you in this term we will have the all the 8 course, and and also have the final examination. So you could join the training online and also join the final examination. If you pass the final exam, we will provide the certification for the NCE training. Okay, let's start today's topic. So as Leo mentioned, today's topic, we are talk about the basic knowledge of NovaStar control system. Maybe some of you work for a LED screen for a long time, but I also met some clients. They are really experienced, but in their mind, there's not a clear view of the what is control system. Because sometimes they always ask me, "Hey Angus, do you have any screen for sale?" But sorry, we are the LED control system provider. So this time we will to see, okay, in the whole LED industry, what is Nova control system? So today we're going to have following 3 content. The first is the system structure overview. The second is how we can calculate the capacities of each output, like how many cabinet we can connect it to one output. And the third is the screen connection logic. With these 3 topics, I believe you will get an idea about, okay, what is the control system? What can NovaStar system do? So first, what is the LED control system? So to be honest, in a lot of person, they know the LED screen, but they don't know what is inside of the LED screen and what is the key parts to make the screen show the image. So the first part, which is very important and the most basic one, is the LED module. Yeah, here the module is the smallest unit in the LED cabinet. From the image, we can see this is the front view of one LED panel, or LED module, and this is the back view of the LED module. So one LED cabinet is composed of LED module. So here we just show you one type of the LED module, but actually in the LED industry, we have following different type of the LED module. The first one, we call it the DIP. This is an old type of the LED module. Normally, we use it for the outdoor screen. Yeah, the pixel pitch of this one is really big, like the 15, 20, 22, something like this. But the technology developed very soon, so we have the second type of the LED module, that is the SMD. We can see this one is better protection and the pixel pitch becomes smaller. So in the past few years, we use this kind of LED module on the most LED cabinets and for the indoor project. But in the nowadays, the technology has much difference than before. So we have the COB technology. From this, we can see, because in the special way how we install the LED pixel on the module, we can have the much more smaller pixel pitch on the COB and has better protection of the LED module. So in the nowadays, you can still find all 3 kinds of the LED module, but the SMD and the COB will be the one you find it very often. Very often. When we have the working well LED module, So we need to make it as the LED cabinet. So here in one LED cabinet, we may have several LED modules. So normally in one LED cabinet, if we want to control this cabinet to show the image, we need one device, which name is the receiving card. Receiving card. With different type of the receiving card, we also need a hardware, which name is the hardboard. Okay, if you're working with NovaStar for a long time, you should know, like the old type, like MRV, MR300. That's really basic and very old receiving card. That one really need the hubboard. But like the new product, like MRV 328, we already integrate the hub card on the receiving card. So with Nova system in one cabinet, the receiving card, the hub card is very important. And then the LD module. We use the flat cable to connect the hub card and LD module. So this is the most basic things in the cabinet. With the working well LD module, with the correct receiving card, hub card, the working well flat cable, your cabinet should working well. And normally, there's only one receiving card inside each cabinet. This is the regular one. But for now, the pixel pitch is becoming smaller. So the resolution of each cabinet becomes bigger. So that means sometimes one receiving card is not enough for one cabinet. So in this case, one cabinet may have two receiving cards, like this. This is normal. If the resolution of the cabinet is bigger, more than one receiving card will be installed inside. But here is one tips for you, because when you use our software NovaLCT in the screen connection, there's one thing that we need to do the screen connection. But in the default settings in the software, one receiving card is regulated as one cabinet in that software. So if you have one cabinet which has two receiving cards inside, then that means in the software, we need to treat it as two cabinet. So here is the first tips for you when you use NovaStar software, NovaLCT. Okay. Right now, we mentioned we have the working well LED module. We have the working well Nova LCT cabinet. Then what we're going to do is the LED screens. So it consists of several cabinets arranged according to a cabinet rules. That means you decided how many columns, how many rows you want in one screen. Then we use LED cabinet to build it up. Then we show as the picture which it shows for the LED screens. It consists of several cabinets. So this is what we have of the LED screen. I think most of you should be very familiar about this. But today we are talking about the control system, not only the LED screens. So we need to show you what is the basic control system structure in this industry. So let's see these following pictures. Now we know how to set up screen. If we want to show the image, what we need is a PC. So here the PC, we use it as the video source. We can see here. We used HDMI, DVI or display port cable to provide video source from the PC to the sending controller. And the PC also acts as the console. We use the USB cable or the Ethernet cable to provide older signal to the controllers. So here is the PC. It provides video source and the control signal. Then we have the sending controller. Sending controller is the things which received image signal from the computer and transfer it to the one which can be shown on the LED screens. So between the controller and our LED screens, we need to use the Ethernet cable. We use Ethernet cable to do the connection. to do the connection. So this is but the most basic one. We have the video source, we have the controller, we have the working wheel cabinet with receiving card. We can show the image. We can show the image on the screen. But sometimes we will meet this kind of situation. The source resolution is different with the screen resolution. So here we can see the example here. The video source resolution is around 1366 by 768, but the screen is only 700 by 500. So if in this situation we only use the sending controller, we cannot show the whole image. We cannot show whole image on the screen. We can only show part of it. We can only show part of it. So if we want to display all the content on the screen, that means a video processor or a software scaling is necessary, which can scale image resolution from the original one to the correct resolution of the screen. So that means we need to add one more device in this structure. So here we just add one more device, which is video processor. So here the structure become the video source, the video processor, the sending controller, and the screen. So after scaled the resolution of the image through the video processor, the image it fits into our screen size, the resolution. So then we can get a complete display of the image. But because we extended the resolution from the original one to the screen resolution, so sometimes the radio of the image is also changed. So here we normally suggest that if we need to scale, no matter the zoom up or zoom down, the original image, it's better to keep the ratio of the image, like always keep it as 16 by 9 or 4 by 3. So this is our suggest. So the video processor and the controller can help us to have the whole image on the screens. So let's see the system structure of this kind of connection. So here we still have the computer provide video source and the control signal. And here we have the signal go through the video processor, go to the controller, and show the whole image on the screens. So this is the very basic one. I think that you always be familiar about this. And every time when we talk about the resolution, we know the benefits of the LD screen. That is, the older resolution we can customize. But here we still want to introduce some standard resolution. So let's say here, as we know, the pixel pitch is getting smaller. The screen resolution on same physical size will be bigger. So as we can see from this image, there are the common standard resolution from the Full HD to 4K. So that's why we need to be the bigger device which can handle the bigger screen. Okay, then we are going to talk about the loading capacity. The loading capacity will influence how many cabinets we can connect for each single output and how many controllers you need for one project. So here we need to know what is the loading capacity, and when we talk about the loading capacity, we don't care about the pixel pitch or the physical size of the screen. So you may wonder, okay, what is the parameter which you care about? The only things which we care about is the total pixel number of the screen of the cabinet. So if the total pixel number is within our loading capacity, we can handle it. If that is overload of one loading capacity of one output, that means we need one more output, or we need Here I give you an example. Here we have the cabinet, which is the 500 millimeter by 500 millimeter. The pixel pitch is P3.91. So how we calculate? How we calculate it? So normally we use the pixel resolution that equal the pixel width by pixel height. So the pixel height, we use the cabinet width to divide it by pixel pitch. We use the pixel height. Pixel height means we use the cabinet height to divide it the pixel pitch. So if the cabinet is 500 millimeter by 500 millimeter, pixel pitch is P3.9. That means the pixel resolution of this cabinet is 128 by 128. So this is how we know the cabinet resolution. So next time, if you talk with NovaStar engineer, you can just tell him what is the resolution of your cabinet. No need to repeat the physical size again. It will save a lot of time. Okay. Now let's use the simple product, the M Control 300, as example to discuss what is the loading capacity. So here, for the loading capacity for each output, that is, if you can check, you can check it on our specification. That is the 650 100 pixels, and the LD for the M Control 300, we have two output on it. So the total pixel loading capacity of the MCDR 300, that is the 1.3 million pixels. 1.3 million pixels. This is the very basic information. You can always find it on the specification. But how we can know how many cabinet can be loaded by one output? This will be the question, right? We need to know how to calculate about it. If we want to know how to calculate about it, we need to know why each output is the we need to know what is the step we're going to calculate it. So here we have an example that the cabinet resolution is 192 by 192 pixels. For each output, that is 650,000 pixels. Here we have very simple way that the cap number equal the port loading capacity divided the cabinet resolution. So for this example, the cabinet number will be the 17. The 17. So the first step we know, okay, for one cabinet, the maximum number of the cabinet, it can be the 17. It can be 17. But have you ever considered why each output, this condition is very important, why each output can drive 650,000 pixels? So actually, we have the formula. Let's see. For one Ethernet cable, the bandwidth that is 1 gigabit. 1 gigabit. And we all know the hardware cannot be used as 100%. There should be something lost during the hardware connection. So we have the usage rate, which is 93.6%. This is the most stable usage rate. Okay, so this is all the things which we can carry by one Ethernet cable. So what kind of information will be carried by the Ethernet cable? That is the loading capacity, the frame rate of the input video source, and the color depth of the input video source. So this two is very important. This is not the parameter of the LD screen. This is the parameter of the input video source. And this is the loading capacity for each output. So if we calculate well, the loading capacity of each one single output under 60 Hertz, the color depth is 8. The loading capacity will be 650,000 pixels. So if we change the color depth, we change it as the 10 bits or 12 bits, no matter 10 bits or 12 bits, we always calculate at the 16. So if we calculate like this, we keep the cable the same, we keep the frame rate same, just to change the color depth from 8 to the 12 or 10 or 12 bits, the loading capacity of each output will be reduced. That will be 325,000 pixels. Because the ability of one cable is limited. So here we share the first form to you, based on the average usage rate, 93.6%. The controller, the loading capacity for each output will be influenced by the frame rate and color depth of the input. So if you want to know, okay, how many total pixels I can handle by one output, you can check this form. Hope this form can help you. So the maximum which we mentioned, that is the 55,000 pixels. That is maximum. Okay. So right now we mentioned the two output controller MCDR300. One port is 650,000, and the two output, the loading capacity is 1.3 million pixels. Okay. Now we're going to talk about the full output controllers. Okay. So here is the full output controllers. Maybe you use it before, or you just know the name. We need to know why we have full output, but on our specification, the loading capacity is not 2.6 million pixels. This is very important, because every time the client will ask me, so hey Angus, why you have full outputs, but the loading capacity on your specification is not 2.6, it's just 2.3 million pixels. I'm sure some of you also wonder the answer of this question. To be honest, this limitation is not come from the output. This limitation is come from the input. Okay, let's see. In our basic product, we use the single link DVI. So here is the very basic resolution, which we met before. Okay, so the maximum resolution of the single link DVI, that can be the 1920 by 1200. So if we calculate like this, the maximum resolution of the single link DVI, it can be 2.3 million pixels. So that's why this is the maximum what they can provide. Of course, that is all should be the maximum which we can show out. So the limitation on the full output controller is not come from the output itself. It comes from the input signals. But here, please pay attention that we also support two special resolution of beyond 2.3 million. That is, these two resolution, the 2048 by 1152, and also the 2560 by 960. So for these two special resolution, our controller can also support it. Even the total pixel number is bigger than the 2.3 million pixels. So here, but here I just suggest when you remember the loading capacity of full output controller, just keep it as 2.3 million pixels, because this two is the special resolution for our system. Okay. So here we also share you the video bandwidth of different type of the input connector. Okay. So I believe you should familiar about HDMI 2.0, 2.1, DisplayPort 1.1, 1.2, something like this. Okay, this is this form you can always get it on the website, but this form maybe you can only get it from now. Here we share the form which we list the name of the controller and the total loading capacity. and the maximum width and the maximum height, maximum width and maximum height. So why we want you to know the maximum, the limitation of the width and height, because we can use this information. We can use we can use the loading capacity of of one device to divide it the maximum width, or then we can know the height which one single device can support. So sometimes it will directly affect what controller you can choose for the screens. Okay. So now we know how many cabinets can be connected, but is it enough? Is it enough for our daily project? Let's see an example together. Then you will know, okay, whether it is enough or not. Okay, here's the example. The screen resolution is 9020 by 1152. And for each cabinet, that is 192 by 384. This really big cabinet. For these screens, we have 10 columns and 3 rows. The customer only have we only have the MCDR 660, this device. And the whole system will be running at 60 hertz. Okay, so we can, from the question is how we can finish the screen connection, or how we can finish the cabling. If we calculate the output, I believe you should still remember the output for each, the loading capacity for each output. If we calculate, we use the loading capacity of one output to divide it, each cabinet resolution. We know the 8 is the maximum cabinet for to be connected, right? So we can easily to have this kind of connection. So this is the final connection that customer sent to me. So let's see whether it is okay. So after the calculation, one output can connect 8 cabinets. So we can check from the interface from this connection. One output, 1, 2, 3. Okay, 8 cabinets should be possible. The second output only 7 cabinets, should be no problem. So if we calculate as the beginning, should be okay. But after we click send to hardware on our NovaLCT software, you will see the following information. Okay, the sending card number 1, the net output number 1 is too much for the loading capacity. It is really weird. We calculate one output can connect 8 cabinets, but why I do it as what we calculate, the system tell us impossible. It's really strange, right? I believe you should have this kind of problem before. So here is one thing I need you to pay attention. So in our system, no matter how you connect the cabinet, like this, 9 cabinet or 8 cabinet, if we calculate, it will be like this. 192 by 384 by 9 is too much for one output. And for this one, 192 by 384 by 8 should be no problem. But in our system, we calculate the loading capacity as the whole square, like this. So no matter you connect 9 cabinet or 8 cabinet, we will calculate as the whole square. So that means no matter you use 8 or 7 cabinet in this triangle, we always calculate as the same as 9. That's why when we click the button on the software, the system tells us, okay, the connection is too much for this first one output. But this client only has one MCDR 660. So does it mean the 660 cannot work with this screen? Actually not. So from this new screen connection, we can see we keep the one output connect 8 outputs like this. So we can change another screen connection. The port 1 loads just 8 cabinet in the first line, and the last output just connect the 6 cabinet. If we do it like this, one single MCDL 660 can control these screens. So from this example, I just want you to know that the way how we connect the screen will influence whether we can use one single device or not. So for this project, finally, we only use one 660 to do the connection like this. We finished this project. So every time when we do the screen connection, not only calculate the pixel number, but it's also consider the way how we do the real cable connection. It will influence the result. So I hope if you didn't realize this before, I hope this time you can understand why we need to consider the loading capacity. Okay, so this is the very basic thing. This is the basic logic of us to know, okay, how we do the screen connection. In the end, let's do a summarize. So for today's training, we know what is the module. We have 3 types of the module, LD module. And what is the basic structure of the LD control system? Not only the screen, including the video source, controller, receiving card, cabinet. Right? And then we talk about the loading capacity. We focus on the pixel level, pixel to pixel. And we know when we know the loading capacity for one output, how we calculate how many cabinets we can connect with it. And after this, the screen connection logic is very, very important. Yeah. So the output is important, how many output is important, and how we do the screen connection is also important. Okay, all these are very useful and basic information in this industry. If you not very clear this before, I hope today's training can already help you. So hope all of you got it.